50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon.
As a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go. We go as the Artemis generation.
We go.
And good evening, live on this Wednesday, August the 24th, 2022. I am James Brierton in Charlotte, North Carolina, and we are bringing you a special edition of the Carolina Weather Group. We are counting down to NASA's big return to the moon. They are going to take their very first step on Monday, just after 8:30 a.m. Eastern Time, we hope, with what will be an uncrewed mission to the moon, testing out the new technology that NASA and so many of us hope will return humans to the moon by the year 2024. It's going to be here before we know it. Joining us from the Carolina Weather Group this week, we have Shay Gibson in Charleston, South Carolina. And joining us, friend of the show, who has been on now 3 weeks in a row, Candace Jordan from the Scheele Museum, who leads up their planetarium. But I feel like there could be so much more to your title, Candace, because you are a lead expert in so much atmospheric and space and weather, and of course hosted the great weatherproof event that we were excited to come back out for in July, and viewers and listeners of the Carolina Weather Group have been reliving for the past 2 weeks. So welcome to the Candace Jordan month of the Carolina Weather Group. Candace, how are you?
I'm doing well. How's everybody else?
We are very excited for Monday's launch. The first launch window opens up at 8:33 a.m. Eastern Time. Bring snacks because it has a 2-hour launch window. And if they don't go on Monday, we'll do it again on Friday.
Exactly.
Yes.
Exactly. Snacks are a must. Luckily, it's at 8:33. And so if you're planning on going down to Florida, theoretically, Florida shouldn't be that hot at 8:33 in the morning.
It is August, though.
It is August. But it should be like, I'll put it in quotations, like that hot.
By comparison standards, yes.
Exactly.
Do you know anybody heading down to Florida, Candace?
I'm heading down to Florida. Now, I'm not going to be at the launch, but I'm going to be at the happiest place in the world, and that's Disney World. So,
yeah.
Can we really complain when we're at Disney World and we get to see the rocket fly up in the air? Like, no, definitely not.
I don't think so. Let's say hello to some folks who are watching. Frogger on YouTube's asking, will we be able to see this launch from Myrtle Beach? I'm going to go with probably. Oh, Candace is going to say yes.
I think a lot of it will depend on cloud cover. Like for yourself, luckily we are in kind of like the more stable part of the morning. But then here recently, we've had a lot of like very morning complexes come through as far as storms. So hopefully, hopefully we will have clear conditions. Do I think you're going to be able to see like fantastic long rocket launch? Yeah, you might see like a little streak in the sky, but no, that little streak is like the biggest rocket we've ever sent. So hooray.
Looking at this animation here that NASA has provided, it is bringing me back to the days of the shuttle mission. I don't know, Shay, when you look at these animations, are you getting those flashbacks, Shay?
Yeah. Boy, I tell you what, I'm pretty excited. I like the intro that you got on the show too. That was pretty powerful.
I can't take any credit for that. Somebody at NASA, but
I'm just saying,
taxpayer dollars paid for that. So
no, absolutely. I'm saying it was a good pick for our intro. It was really good, from NASA. But you kind of reiterating on Candace's thoughts about seeing it, from Myrtle Beach with the sun rising from the east early in the morning like that. she hit the nail on the head. You might see a little streak pretty high up in the sky, but it will not have that big, like streaking effect across the night sky that you would expect, unless the launch gets pushed into the nighttime, right? Because there may be storms and the whole thing may get scrubbed until an evening or nighttime launch when it's a little bit more stable. So we'll wait and see. If it's a nighttime, and there again, it depends on how much clouding is over the area, and we have had an unsettled pattern. So I think it might clear out by Monday. It may have a pretty good chance, but then again, that gets into forecasting, which we're not doing tonight.
We're not doing the space weather forecast tonight. However, shameless plug, if you want to learn how the Air Force, or I guess the Space Force at this point, forecasts for these launches, and you want to learn about their network of lightning detectors they have all throughout the Space Coast of Florida, we have past shows on that. But the purpose of this, what is really a test launch, Candace?
Yeah.
What does this cue us up for in the years ahead?
Yeah. So first off, that video that you saw in the opening, a lot of those people that you saw in there kind of making little remarks are actual astronauts with the Artemis mission. So some of those faces you might see might actually be on our crewed launch. Now that'll be Artemis-2, not Artemis-1. The only person really going on Artemis-1 is a mannequin, and I think he's like either Commander or Captain Mannequin Campos.
It's not Snoopy. Name. I was hoping it was going to be Snoopy in space.
I know, right? But they have a mannequin on board, but the stakes aren't, I won't say as high for Artemis-1 because there is no like crewed, like real people on there. But this is a really good test of our rockets. This one that you're seeing right there on your screen, this is our biggest rocket to date. This thing weighs like 6 million pounds, like when it's sitting on the rocket like launch system. So, I mean, first off, kudos to that ground for holding that up. But I will say 5.2 million pounds of that is just the fuel. Like, just the fuel we need to leave Earth. It's extremely hard to leave our planet. I don't think a lot of people realize just how much fuel you have to take. You fill up your car and, depending obviously on your car, you're going to put somewhere between 12 to 30 gallons of gas in there. But compare that to your car's weight, where this is like all fuel, little bit of rocket there. So, yeah.
What kind of fuel? Do you know any of the properties of the fuel? I've always wondered, what is in that fuel that makes it so powerful?
I'm not 100% sure on exactly what they have in it, but I want to say that there's some liquid oxygen likely in there. Lots of what we would consider gases that are actually cooled down to be liquids. And then when they ignite, boy, they can send it up. They get a lot of thrust, and that's what we need to leave Earth. They've got some really cool animations here. So what you're seeing is a lot of these stages kind of separating. So you've had your main rockets, the boosters will separate, and then your first stage will separate. And then it gives way to the Orion capsule, and that's what's going to be going around the moon. So we're not actually landing on the moon for this particular journey. We're going around it. We're actually going to go kind of the furthest away from Earth we've ever been with a mission like this. We're not counting like Voyager and even James Webb. This is like as far as what could become a crewed mission at some point. This will be the furthest point we've ever been. But we're going to kind of go in this like figure 8 pattern, get some really cool pictures of the moon, kind of see what our capabilities are. There are some like very miniature kind of like CubeSats or nanosats that are also going to be along board. So those will probably end up somewhere on the moon. You can see here kind of that figure 8. We'll do a few loops, a few ovals around the moon. A lot of text on here. I encourage you, if you have time, to actually go through and read some of this, because it's a lot to take in, but basically a lot of it's just like, here's when we'll deploy this thruster. Here's when, we're going to basically change our trajectory so that we can make it back to Earth. Here's when we need to do stuff to get to the moon. Lots of orbital mechanics. There's your science word of the day.
It's amazing the math that goes into the trajectories, because everything's in motion. The Earth is turning, the moon is rotating and revolving, and it's just it's just crazy to know that how much math is going behind this automated sequence.
And really, if you want an existential crisis of the day, it's like the Earth is moving, the moon is moving, we're all moving around the sun. The sun is like part of our solar system, which is moving around in our galaxy, and our galaxy is moving around the universe. So there's your existential crisis of the day, is that we'll never stop moving.
I can barely get to work in the morning. I can't think about all that. Watching this animation, it always amazes me with these launches, how much equipment we start with and how much we end up with at the end.
Yeah. And what you're seeing there, one critical part right there is when we start to come back to Earth. I mean, it looks like you're still in like the blackness of space. What you're doing is you're starting to hit a few of those air molecules. And the closer you get to Earth, the more air molecules you encounter. So if you wave your hand in front of you right now, you can actually feel the air on your hand. There's a ton of air molecules right now around your whole body. But when it first starts, right there, that heat shield's going to start heating up. There's lots of friction as we hit more and more of those air molecules. And that heat shield will take a brunt. It will get up very, very hot. And it's amazing to think like that won't melt. It doesn't disintegrate away. Then they'll release that heat shield, and then the Orion capsule launches some parachutes, lands safely in the ocean. So pretty awesome. I think it's going to land off the coast of California. And they'll go and they'll grab that capsule, and if it's able to reuse, they'll reuse it. Otherwise, they can reuse some parts and things from it. But if anything, they can look at it and kind of test and be like, wow, this part did really well, or maybe we should rethink it for Artemis 2.
SpaceX has set that bar high for reusing things. Now, the mission duration will depend, as I understand it, on which launch day. Going back to that whole, where is everything rotating and where is it in the universe when we launch? The mission's going to last somewhere between 26 days and 42 days, starting as soon as Monday. And we'll see.
So a lot of people don't realize, we have these different launch windows, so we have a 2-hour launch window. It's basically 8:30 to 10:30 on Monday morning. If we get past 10:30, they're like, can't do it. And then you're like, wait, why do we have to wait until Friday? Like, that doesn't make any sense, right? You're like, the moon's right there. The way everything is moving, the moon is orbiting around us. Think of it kind of like if you accidentally take the wrong exit on an interstate, and then it's like, man, now I got to take a little bit longer detour. It's going to take me an extra 2 minutes to get there. An extra 2 minutes in space world can mean a whole lot of extra fuel. It may mean that parts don't work as well. So they have to hit these windows very specifically. And usually it's about 2 weeks on, 2 weeks off that we have these really good windows to reach the moon. Now, when we were doing the Mars Perseverance rover, it was like, okay, we've got these few weeks. And then if we don't hit this few week mark, it's going to be months before we have another one. So the further out you're trying to go in space, the bigger those launch windows can kind of be in between the good times and the bad. So luckily with the moon, it's an every 2 week, we get kind of like thumbs up, thumbs down things.
So you're trying to get the window when you're closest to the moon. That's it.
Yeah.
Yep. Cool.
You want to capitalize on it. It's like taking an Uber. If you're already 3 miles closer, guess what? That's 3 miles you don't have to pay for. Like, yes.
And looking at NASA's available launch opportunities, we have 12 between now and September 6th, essentially, with some blacked out dates. But this could go, and oh boy, I hope it doesn't take this long. It could go all the way into December, on and off again with different opportunities. So fingers crossed. Now, I want to circle back to a point you made a moment ago, Candace, because you mentioned the Mars rover and the big red planet. How does Artemis and our return to the moon set our scopes on Mars?
Oh, love this question. So I don't know, James, if you can find a picture of the logo of Artemis.
Okay, I'm on it.
Yes. While he does that, we'll explain. So basically, we want to say if we want to go to Mars one day, because that's kind of like every space geek's like thing. We want to go to Mars. We want to try to establish a colony on Mars. We want to do cool things on another planet. Well, before we can do that on Mars, it's kind of like, why not test it out on our own moon? If something's going to fail, at least we're failing 240,000 miles away versus, like thousands and thousands and thousands of miles away. And, 7 months away versus 3 days away. It's like, let's trial and error here. So yeah, you've got the logo here. So kind of parsing out this logo. The blue that you see there, it represents Earth. You've got the moon kind of like pointing us to the moon. And then you've got this red trail, and it's like taking us to the moon and beyond. And that is representative of going to Mars. So what we're going to try to do is once we get our crewed missions, eventually Artemis program is going to lead to this thing called Gateway. So if you haven't heard of Gateway, don't worry. It's still kind of a new and upcoming thing people are learning about. But basically think about it's going to be kind of like how we have the International Space Station around Earth. It's going to be this spacecraft that goes around the moon, it orbits the moon, and it'll allow us to establish some temporary colonies on the moon where people can temporarily stay. We can start building some outposts there. And if all that's successful, then like, great, we have now a good template to go to Mars with. And if we can kind of get established on the moon, we can send stuff up to the moon and then rocket it to Mars. And we don't have to have all that weight, to take it to Mars.
I'm hearing moon base.
Yes.
Yeah, that's really, really interesting.
Moon base alpha.
Yeah, I mean, I remember that was like a reference in like the 007 movies with Moonraker, right? They had a space station that they would launch rockets from. But yeah, that's really, yeah.
You can.
Are you saying James Bond came up with this mission?
Oh, maybe. But you can take like a block of, or like filament for a 3D printer, and like 3D print different parts that you would need to go to Mars. And it's like, it's much cheaper to, take a bunch of plastic, kind of compactly that you could feed into a 3D printer versus having everything already built, and it's going to take up more space. So, that's kind of the hopes, is that you can start doing things like that. On the International Space Station, they now have a 3D printer that they print their tools all the time. So if they need a specialized tool to go for this special bolt that's somewhere, they can just print it out. 2 hours later, great, they've got their tool they need and they're fixing whatever they need to use. So it's very resourceful. So that's kind of our logic going into Gateway.
That's better than waiting for Amazon Prime delivery in space. I hear it's really slow.
Definitely not the Postal Service. Sorry, you.
Shots fired. So we will anticipate that if all is continuing to go well in the preparations, that NASA will begin these countdowns. I think it's about 10. I was going to say 10:15. I think I'm rounding, and maybe 10:20, 10:23 on Saturday morning is when the official launch countdown will begin for the 8:33 a.m. Monday launch window. Here on the Carolina Weather Group YouTube channel, you'll be able to watch that launch. NASA TV will have coverage beginning at 6:30 a.m. on Monday. And I should mention, as we've been looking at some great animations and looking at great maps, if you're listening to our audio podcast this week, we love you very much. And we're glad you're subscribed to the audio podcast. If you want to check out any of the pictures we were talking about so far, 2 ways to do that. If you're listening on Spotify right now, you can actually flip open your app and sync right on over to the video. It's a cool Spotify little feature. They don't pay me to say that, but it's a cool feature. Or you could find the link to our YouTube episode in the description. We will anticipate NASA give us that update by Saturday morning, find out whether or not we are a go for Saturday, or for Monday. And again, that next launch window then will be on Friday. Candace, how is the Shield Museum in Gastonia? If anybody doesn't know, outside the Charlotte area, how are you guys tracking all of these missions over the next couple of years?
Yeah, so a lot of it's me, but
that's a good resource.
Yeah, I know. Well, we run the planetarium daily. So one of the great things is that coming up, starting September 1st, we're going to have a program all about Artemis, and it's called Forward to the Moon. So if you really want to learn about the Artemis mission, kind of get all these like really cool fun facts and like different things happening, that is a program that we'll be playing throughout the fall. We'll also have our Sky to Night program that also highlights different things like, from the constellations you can see from your own backyard to planets. And then we dive into things like the James Webb Telescope and Artemis. So give you a little bit of science nerd, but it's kind of like science nerd for the family. So my goal is that even the toddler has fun in that program.
It is toddler approved. I can verify that. We are going to talk about the James Webb Space Telescope and the sound of black holes coming up after this break on the Carolina Weather Group. Candace mentioned earlier that we do know who some of the astronauts will be on the upcoming Artemis missions in the years ahead, and one of them has ties to North Carolina. She'll look familiar. Take a look at this.
Today's spaceflight will be the very first for NASA's Christina Koch.
We have to answer humanity's call to explore. We have to set ourselves as the leadership in proactively seeking out challenges and learning that when we focus on one thing and we focus on it together, we can achieve anything. I am someone who has loved exploration on the frontier since I was little. I used to be inspired by the night sky, and throughout my career, it's been this balance between engineering for space science missions and doing science in really remote places all over the world. I loved things that made me feel small, things that made me ponder the size of the universe, my place in it, and everything that was out there to explore. And I put that stuff to work making science gadgets for NASA space science missions and working really hard in that career, but also setting goals in hobbies that I had. I learned to rock climb, I learned to sail, finally learning surfing at this point in my life. And so I think working hard on all fronts to be a better person and to contribute the most to the world is really what's important to me. I really don't remember a time when I didn't want to be an astronaut. For me, I learned that if I was going to be an astronaut, it was because my passions turned me into someone that could contribute the most as someone contributing to human spaceflight. So I didn't necessarily live my life according to checkboxes of how you can become an astronaut, but I followed those passions and one year looked at who I had become and the skills I had gathered, and I asked, could I sit across from a table and present myself as someone who could do this well? And I thought, I'm going to give it a shot. You know, there was a moment where it came to me that this was the most exquisite personal and professional moment of my life, a moment of career culmination where everything I had learned personally, professionally, every skill I had been taught, every hero I had emulated, it was all coming together in this moment. And I realized that I wanted my work to tell every single person on Earth that they could have that moment too if they worked hard for it. And I wanted every single person on Earth to feel that same feeling.
If you enjoy really cool stuff. Christina was born in Grand Rapids, Michigan, raised in Jacksonville, North Carolina, graduated North Carolina School of Science and Mathematics in Durham in 1997 before enrolling in North Carolina State University in Raleigh, in which she earned 2 Bachelor of Science degrees in Electronic Engineering and Physics and a Master of Science degree in Electronic Engineering before graduating in 2001 from the NASA Academy program at the Goddard Space Flight Center. It'll be really cool to see her in space in the years ahead. All right, before we go, go ahead.
Oh, I was gonna say we've got a few comments here talking about like just how huge of a rocket this is. Mm-hmm. So I see like Frogger and then Bassman Bray said it like this SLS, so it's a Space Launch System. It's taller than the Statue of Liberty. So the Statue of Liberty is like 305 feet tall, and this one's about like 322 feet tall. So that kind of gives you like some perspective if you've ever been, seen the Statue of Liberty. And it's also going to give us about 8.8 million pounds of thrust at launch. So that's about 13% more than the space shuttle and about 15% more than the Saturn V rocket did with the Apollo mission. So people who are going to be close to this launch are going to feel it. And like, I know NASA had like a ticket that you could get. It was like, feel the burn or feel the heat or something. I'm like, that is awesome. Like, you are going to feel it. Like, I could not wait. I hope there are some seismographs nearby because you're going to be able to see that on seismographs and it's going to be epic.
I'm looking forward to it. I remember where I was when the last space shuttle went up, and I'm looking forward to getting humans back exploring space. It's going to be really, really exciting. Before we go, Candace, we had 2 other space topics we want to hit upon, starting with some amazing new pictures of Jupiter from the James Webb Space Telescope. You've taken a look at these already.
They're gorgeous.
Podcast listeners, I'm sorry. You're going to have to just click on through to look at these. Walk us through these.
Podcast listeners, listen, we are looking at Jupiter. And you're not seeing it in like the colors you're used to with like the reds, the yellows, the whites. This here is a little bit more subdued. It's a little more like almost grayscale. But if you've ever seen the Great Red Spot, it is white on this here. And that's really indicative of those higher cloud tops. And so you are literally seeing this hurricane on Jupiter just like stand out. It is like white on black, and it's beautiful. And there's so much detail in there. It's gorgeous.
This telescope is amazing. And I mean this non-sarcastically. Are we looking back in time at Jupiter here with the way that the James Webb Telescope works, or we're not that far out in our mission yet?
I mean, technically, you looking at your computer screen, you're looking back in time.
That's fair. That's fair.
Anything that your eyeballs see is milliseconds late.
So yes,
but
fair enough.
But we're not necessarily looking back in time because Jupiter is so close to us.
Mm-hmm.
We're probably looking minutes into the past, but so not really looking back in time, but it's really James Webb is helping us see in the infrared view. So as the further light travels, it stretches. And as it stretches, it becomes more red. So we call this red shifted. And so we are able to see things in the wave-like spectrum that's beyond red. So our eyeballs are really only great at seeing from red to purple, and then anything outside of that, we don't see. So this is seeing heat signatures. So that's one reason that cloud top there on the hurricane's really starting to stand out. It's really cold cloud tops. We use that same technology when we talk about weather. You're looking at radar or satellite imagery of Earth. We look for cold cloud tops, and that's indicative of very high thunderstorms. And typically the higher the thunderstorm, the more intense or more they've grown. So same technology that we're using, just in a different application. But on that video or that picture of Jupiter, you can actually pinpoint the rings of Jupiter. So I think it was the one that was down below.
There you are.
And a lot of people don't realize that Saturn's not the only planet that has rings. Jupiter, Saturn, Uranus, and Neptune have them. They're just really, really faint. And so here you're getting to see that view of the rings. There's the aurora. So just like we have the aurora borealis, the northern and southern lights, Jupiter has those as well. If you have time after this show here, just do yourself a favor, Google Jupiter auroras. They're beautiful. You're seeing lots of different moons present there. So Jupiter doesn't have the most moons. It's got 79, but Saturn took the cake in 2020 with the most moons. It's got nearly 90, which is just mind-boggling on its own. Now, not all of them are wonderful. A lot of them are that's a piece of rock, but it's doing everything it needs to do to be a moon. But
they're still mapping them. I think there was 86 a couple of years ago, and my little boy was all into this. He knew how many moons every planet had. And now I've got to go back and tell them it's 90 now. But they keep mapping more and more.
About space is you learn stuff things that I learned back when I was in grade school. It's almost obsolete now, but it's our technology is growing. Our space industry and really the big technologies are only within the past 100 years. It's a very quote unquote new branch of science, even though we've studied the stars almost forever. We're studying them in a different capacity with better technology. So it's kind of the weather and space industries are the babies of the space world, and it's every day we learn something new, and having James Webb out there just gives us an excuse to look at the universe in a different way. And it's wonderful.
Yeah, really cool. Why have you on? Quick question for you. Pluto, poor Pluto, right? Is there ever going to be another consideration to reevaluate it as a planet, or is it going to always remain a dwarf planet?
Oh, okay. Let me put on my planetarian voice for you about Pluto, okay?
Okay.
Because
all right, we're listening.
I try to be an optimist, and I hate when people are oh, Pluto got demoted. And I'm no. Pluto got promoted, okay? Pluto made us completely reconsider how we classify objects in our solar system. So really, without that, we wouldn't have had this new structure that we have. So I like to think it got a promotion. It really helped us change our policies. Now, one thing in order to become a planet, a standalone planet, is you have to clear the junk out of your orbit. So all this space dust, all that stuff has to be cleared away. That's why when you look at Earth, we go around the sun. Yeah, we have meteor showers. We run into a little bit of dust, but you don't see big asteroids bombarding us all the time because Earth is cleared away in its path. Well, Pluto.
My office would not qualify as a planet.
Exactly. Yep. Not a planet. Not a planet.
No.
It's crucial. But Pluto, because it's in the Kuiper belt, it's in the asteroid belt. So there's other stuff in its vicinity. It doesn't necessarily hit it, but it's not clearing it out. Its gravity is not strong enough to clear it out. So it won't become a planet. Also, Pluto is half the width of the United States. So little tiny guy, little tiny baby thing out there. But I always tell people that are like, people who they get so invested in Pluto, and I love it.
Yeah.
But they'll be like, well, Pluto's a dwarf planet. And I'm like, say that again. And they're like, it's a dwarf planet. And I'm like, you said the word planet, though. So technically it is a planet. It's just the dwarf kind.
It's pretty neat. And it is even like the other ones like Maki and Haumea, and they even have moons, right? They can have a moon too. So even smaller. But, it's to me, it's amazing that Pluto was even seen back when it was seen first to even identify it as the planet. I mean, holy moly. We have a tough time seeing that far out now. Like back then, it was like a speck,
Yeah. You're literally looking at like a pixel. And it's like, oh, this pixel's moving. It's got to do something, imagine staring at your TV long enough that like you saw a pixel move. Like,
it's like it's an asteroid. No, it's a planet. No, it's an asteroid. Okay, I'm gonna wish cast this into a planet now. Okay, there it is.
That's the reason we have things like planetary nebulas. It's not because the nebula acts like a planet. It's because through early telescopes they looked round like a planet, but they didn't behave like one, so it became a planetary nebula. Nothing to do with planets.
Is this the part in the YouTube video where I tell people to leave their comments in the description below and subscribe and hit the bell and let us know what they think about whether or not Pluto's a planet?
Hopefully I've convinced you.
Sorry, open up the can. I just had to ask because we're talking about planets
ready?
Now, so. Yep.
Get the fuck in there. All right, we got one more cool space thing, and this is the sound of a black hole.
Yes.
I have not yet listened to this.
I haven't either. I'm excited.
This is going to be a live reveal. Shay, have you heard the sound of a black hole?
Not yet. I'm waiting to hear it now, though. If I have any idea, it may sound like our own planet's harmonic noise signature that we have. But
I kind of hope it sounds terrible. I don't know why, but I do.
Like a really old recording.
Oh no, like a fork on a spaghetti plate, because spaghettification happens in a black hole. I want it to be like that, like
nails on a chalkboard. Is that what you're hoping for? Okay, here we go.
I don't know.
All right,
yourself, ladies and gentlemen, the sound of a black hole. Is that it?
It goes all the way around.
Wow, that was multi-layered. There was at least 3 different signals going on there. I mean, that is intense.
Okay, do you know how do these work?
No. How do these work?
So I've listened to sonification before. I haven't listened to this one specifically, so that was really new for me, and it was great. But what they do is they typically take how far away it is from the center, because that was doing kind of almost like the radar sweep around the video. So it goes how far away it is. It does the color intensity. So if it's very, very bright, it's a louder pitch typically, or it might be a higher pitch. So that's kind of how you can hear those intricacies within the video. It definitely gave me like some Halloween vibes. So I'm like really excited going into Halloween, like to put a black hole in the planetarium dome and like just let it itself out.
Yeah, if this makes any sense, it sounds like I'm listening to an orchestra underwater.
Yeah, I get that vibe. Yeah.
Yeah. You should put it on and just see how long anyone goes. Is that the sound of a black hole that you're playing?
I mean, there was a lot of reverb in it too. There was definitely, I mean, that's wild. I wonder, is that something we can hear? We would not be able to hear that with the human ear, right?
No.
I mean, that's
so these are, it's like audio to describe the sound. Or excuse me, to describe the picture. So, if you were actually standing for whatever reason, like in front of a black hole in that image, first off, there's no air in space, so you wouldn't hear a thing. But if there were air in space, you would likely just be deafened. If we had air between us and the sun, we would all be deaf right now, because the sun emits just so much noise. And so imagine having, the multitude of suns that are around a black hole. I mean, like, your eardrums would be gone. Your face would probably be gone too. That's fine.
There's a long list of problems. I mean, this analogy.
I got 99 problems and the black hole is one. So.
Imagine you're standing in space and then ask yourself, Why am I standing in space?
Now the trick is, how do we get the sound of a white hole?
Oh, I mean, I guess just play that backwards.
Then it just says Paul is dead.
Good one.
Well, Candace, we've had another blast with you. Thanks for coming back onto the Carolina Weather Group again.
Of course.
Hopefully people, if they haven't already, will go and check out our 2 most recent episodes where they can relive some of the great exhibits that you had at the Shield Museum for the Weatherproof event. We were so happy to come on out and meet so many fans out there in Gastonia. And in one of our episodes, you teased that it'll be back next July.
Yes, we haven't set an official date yet. We're working on the winter calendar right now, so we'll get there eventually. But yeah, look for July of next year. We'll have Weatherproof back. A really fun time. Come out to the museum. If you are any kind of nerd, we have the nerd for you. So like we have space, we've got our Katabi Indian Village, gemstone mining. We have a whole farm with live animals. So, if your thing is to like go hang out with goats, we got 3 of them there. They're awesome. They'll talk to you too.
Imagine you're in space with goats.
With goats. Bleh.
Oh, well, it's going to be fabulous. Hopefully next week we're back. We're talking about the launch of Artemis and not the impending wait of the never ending. We will hopefully see Artemis take off Monday morning at somewhere between 8:30 a.m. and 10:30 a.m. from Cape Canaveral. Candace will be perched atop a tree in Florida trying to see out to the coast from her position in Orlando. We invite you to watch that launch right here in the Carolina Weather Group YouTube channel and other platforms. We'd love to hear your excitement, and you can comment right now wherever you may be watching the show. Candace, always great to see you. You as well, Shay. And that's going to do it for this edition of the Carolina Weather Group. I'm James Brierton, and stay tuned. Subscribe to our YouTube for continuing Artemis coverage.